Hello and welcome to this video, in which I want to exchange some lifetime with knowledge again. I know, I'm a little late to the party with Flux, but well, it also cost me a bit of time to work in Flux in addition to the hustle and bustle of everyday life. And yes, it is also a bit slower than the other models we know, so it all took a bit longer, but it does not run away from us. So I try to create an overview in this video about what we currently have and can do with Flux. A few things may not work that way, because I have to be honest, my hardware is also totally at the limit. This is a negative point of Flux, unfortunately, the size and the VIM need, but we'll see that we can get through there as well as possible. So, let's start with Flux Dev, the original model. There is still a Flux Pro, but that is not available for us, but Flux Dev. Take a look at the license. Of course, it is not usable for commercial purposes, that is forbidden. Fast later is usable for commercial purposes, and Pro, as I said, only via an API, but more on that later. So how do we get into Flux Dev? A good starting point for this is when we go to the ComfyUI page. So there it is, and then click on examples down here, then we see a Flux writer here. And here we have actually already described everything we have to do. First of all, what do we need for this? Where do we find the models? We need two text encoder models, the T5 in the FP16 or in the FP8 version. Here is the FP16, here is the FP8 version and a clip L. You may already have a clip L lying around on the board, which you also needed for other things. Just click on this link here and then you come to a download page of Comfy Anonymous, where you can choose between the FP16 and the FP8 version and the clip L. Download the whole thing that comes in your clip folder. Here they are, 8, 16 and the L version in your model's clip folder. You can download it so that ComfyUI can find it there. So next we need the VAE to encode and decode pictures. Here, too, the link is given. Click on it and you can download the VAE here. This is the AE.SAFA tensors. Then as the next step, of course, we need the model itself. Here, too, we find the link directly on the page, which is here. You can find the Flux Dev diffusion model weights here. Let's take a look at that, too. Then we come to the model card on Hugging Face, and here under Files and Versions, we find the Flux Dev Safe Densus model. By the way, here is the VA again, but you can also download it here. But we need this here. And here we see 23.8 gigabytes is the whole thing big. And if you consider that all of this somehow fits into the RAM VIM or vice versa, VIM RAM, that hurts. Especially if you are not the owner of a 4090. Yes, as I said, with my 3080 Ti I also come very close to the limits of the hardware. I can generate pictures, but it takes time and often it is also the case that the computer somehow gets stuck. And I have to download and reload the models and things like that. In any case, the model weights come, as described here, in the ComfyUI models.net folder. That's this one here. I also have folder structures here for me. Here under Flux I now have the Flux Dev model up here. Pack it in there, even then it will be found. And the next step you can then just go and say, I take this picture here. I drag this over here in my ComfyUI UI, drop it there and we get the workflow for Flux Dev. The whole thing looks a bit confusing at first glance. Because we have our sampler custom advanced in here. This is a cool thing, but we can also make it a bit simpler for the entry. Let's build it around a bit. First of all, what I'm going to do is, of course, I have to enter my folder structure here. I'll take the FP8 T5 model for testing. We leave clip L. And I also have to enter the VAE with the folder so that it can be found later. How can you set up the whole thing now? And clean up, above all. Width and height, I'll pack a little bit down here. We have an empty SD3 latent image here. We leave that too. And not quite through with testing either, but I've seen that it might be quite practical to take that. It also works with a normal empty latent image. But SD3, I mean to have seen that the normal empty latent image has 4 channels. And this here 16. That has already caused issues for me with some tryouts to take a normal empty latent image. That's why we'll stay with the SD3. But what we can do is, we can first of all throw out the custom advanced and everything that goes with it. The random noise, K-sampler select, basic scheduler, model sampling flux we leave. By the way, we can also turn that off if we want to. That's down here in the node, but we leave it on. Then I would like to have another saved node so that I can throw it directly into a folder. We can already connect that. And we can now replace the whole thing with a normal K-sampler. And here are a few things to consider. Up there, the basic guider can also be removed. Let's first connect everything we have here. We take the model from down here, pull it up here, take the positive and take our empty latent. Flux has no negative prompts. But our sampler needs some. We can't enter any negative here. That's why we do the following here. We just take a conditioning 0 out. That's as if we were sending an empty conditioning. Just take our positive prompt, chase it through and hang it in a negative. But what we still have to pay attention to in the sampler is that we put the CFG to 1. If we put the CFG to 1 in the sampler, then the sampler ignores the negative prompt. And that's how it works. So it doesn't complain that it's missing a negative prompt. Then it all works again. To reduce the RAM load a bit, we could also turn on more precision 8 calculations up here. But I'll leave it to default now. You can play around with it. It might help to squeeze out a megabyte of RAM here and there. But on the whole, it doesn't make a lot of difference. So now I've prepared a prompt. Let me copy it over here. And here we have a cyberpunk woman in a Tokyo-like city. Everywhere is neon lighting. It is raining. The woman is wearing a brown leather coat, short black trousers, a green shirt with the print Flux on it and blue fishnets. Her hair is dyed pink. So that's one strength of Flux. The prompt adhesion is really very good. You have to say that. Prompt adhesion means, if I now enter different characteristics like brown leather coat, short black trousers, a green shirt and her hair is dyed pink, then Flux gets that pretty well taken apart. With the smaller models we always have a strong bleeding. You might know that. You enter a color and you say a green shirt and suddenly the curtains in the background are green or there are other green objects in the background. That's bleeding. Flux has that pretty well under control. But that's no wonder, because Flux is a 12 billion parameter model. For comparison, the Stable Diffusion 3 model medium, which we got from Stability AI, was a 2 billion parameter model. And now we have the 6-fold of parameters in there. That's good for image generation itself, because of prompt adhesion and so on. But where it's not so good, it's of course, we see it in size. The thing will of course also be huge and then kicks a little bit. The hardware you have locally, a little bit to the side. It's still on the edge, on the 4090 level. I've also heard from people who have managed to run the whole thing on a 3060. It all works, but it sometimes takes forever because ComfyUI also has to work very hard in terms of RAM management. That's a bit problematic. We'll see if the whole thing works. I'll let it run once. I'll push it back a little bit. And then we'll see what comes out of it. So there it is already finished. Of course, I've accelerated the video now. In fact, the whole process took me 3 minutes now. 182.99 seconds. That's a house number. But we'll take a look at the result. What did we do now? We said cyberpunk woman. Yes, you can let it go through. Tokyo-like city. We have to talk about it. Neon lighting has hit. It's raining. You can see it here. Here we clearly see the rain. So now comes the interesting thing. Brown leather coat, check. Short black trousers, check. Green shirt, check, with the print Flux on it, check. And blue fishnet. Yes, clearly blue. And her hair is dyed pink. I think we can confirm that too. This shows how good the prompt data of Flux is. But if we run through several batches now, or several pictures, I did that in advance with this prompt, then you will also see very quickly if the model has chosen a path once, then it stays there too. That means the pictures we get out are all very similar to the ones we see here. So sometimes it's hard to prompt to tear the model a bit in the other direction. Then you have to try very hard with it. So the model is a bit stubborn here. It makes very good pictures and it follows what we enter. Mostly, but if it has the direction, it stays there, and then you really have to try a bit with prompting to tear it in the other direction. To prompting itself. Of course you can with basic prompts. So this is actually a basic prompt. You can do a lot. Even better, however, is if you really elaborate descriptions, so roughly as if you were from ChatGPT or get an imaginary description of an image. You can also try it out. Go into ChatGPT and describe the following scene in detail. Scene X, which I want to have. Throw the prompt in here and let it run. The more detailed the better. There is also a little issue. The model also ignores here, and there are also certain texts. This could be due to the fact that we have a very large model here. And if you now imagine a lake, aka a stable diffusion model, on it are swimming boys with different terms, woman, man, beard, hair, whatever. Then this boat has to find a way through this lake and take as many of these boys as possible. The lake is our little model. But now we have a sea with flux. So even there these boys swim on it, and the distances are of course much further apart. That means our ship will try to take a path through this sea and take as many of these boys as possible. But some are so far away that it doesn't even get there, and that's why it ignores these terms. You can also try to use other terms. That you get the tokens on the course of your ship. Where Flux is actually pretty good is Img2Img. We can do that once. I take a load image node and take our woman with a dirty face. I have to convert the whole thing to SDXL ratios. Resolution by aspect ratio. SDXL. Now we have our width and height here again. We can hang it in here. We take that away first. Of course, we also have to hang the node back here. Or we take a resize image. We also say width and height. We take that. We take lanchos and I take crop for safety. Where is my image? We need the VAE. We take it from up here. We take that as latent image and say Dino is 0.5. If I run the whole thing now, I hope it works. It has become very similar. The image quality is very good. I will turn the Dinois a little higher. Let's say 0.75. So that we get a little more prompting influence. That's better. Here he tried to make pink dyed hair. We have the green shirt and the brown leather jacket. Here we see a little bleeding. I think that was a little unfair to say with this picture. We want blue fishnets. Nevertheless, the blue has bled into a kind of tattoo. But you can still see you get pretty good Img2Img pictures. Even if it is now given a bit through the Img2Img with the bouquet in the background. By the way, it is also a negative part of Flux, that such portrait photos or photos with a motif in the foreground here is the background always very strongly covered with bouquet. This is really partly a problem to get rid of this bouquet again. Then we have to think of something else. It can help a bit if you have a second pass. But so really good, I haven't figured it out yet. Oh, maybe I forgot to say at the beginning. Up here Flux Guidance. This is our new CFG at this point. Turn down a bit, hold more to the prompting, turn up a bit, give more to the model. Because we have CFG on one here, we have to play around with the Flux Guidance. But we'll probably come back to that later. Now I have to take a quick look at my notes. Exactly, noise injection. If you want to do a noise injection, then it works as follows. We can change a bit here. We take the K-sampler away and take a K-sampler advanced. There it is. Here we also hang in our model. We hang our positive up here from the flux guidance. Zero out the negative and we take an empty latent again. So CFG important to 1, the rest we can leave as it is. Add noise enable, return with leftover noise enable, and now we copy this sampler once and hang the latent over here. And here we say disable and disable. And hang that over here. Now we can hear at this point, if we say we have 20 steps in total, we want to stop here from step 10. The second sampler should start from step 10. Then we can now hang and inject latent noise from the essentials in between. So, hang it over there because the preview will happen again under the samplers. And we put that up a bit to 4, 5, and now we can hear noise injection and get a little more details. I'll run that now. That down here does not interest us at all, so this whole area here is irrelevant right now. By the way, if you mark all and press CTRLG, you can make a group around it. I'll let it run. We still have to outsource the seed. Noise C to input, noise C to input, double click and take randomize. The two hang in here. So now I'm a little confused. Now we have generated our image with noise injection. Down here the model has failed a bit. They were originally here. I think you can see it here. Between the two pictures you can see very well that the noise was injected here. By the way, you can also do an image-to-image with noise injection. For this I take again down here from my load image area the latent image, hang that in here and set here for example the start step 1 to 3. We have to see if that works or if we have to go a little higher. Yes, we have to go a little higher. What's that? Wait a minute, I'll cancel. Let's say 5. There was such an anime style at the beginning. So now we have here jumped 5 steps, aka took our picture. First do step 5 to step 10. Sample once, then inject the noise, and from step 10 we let the picture end the noises. That would be image to image with noise injection. With the original setup, I'll load that again. We take the picture again here. I'll build 1 or 2 things again very quickly. Folder, FluxRec I had taken. We have to load the Flux Dev. Here we take the FP8 and a VAE. If we want to work with the sampler custom advanced, we can also make a noise injection. I'll just show you because it's really cool. Let's just copy the thing. So the picture there, please wait a minute. Unfortunately, this is a ComfyUI bug that suddenly some pictures are still displayed. So now we have to take the denoised output here. The output up here still has a little bit of remaining noise. The denoised output is clean, so we put it here in the VAE decode. What we have to do here now is, of course, make our noise injection again. We had 4.5 there. That means we take the output here, hang it in and hang it here as a latent image again. We have that as before. To separate the two samplers here, we take the split sigma's denoise node. And if I go here now and say 0.6. No, let's stay at 0.5, we just had that too. That means that from 50% the samplers should be separated. Now we take our sigmas from the first sampler, hang them in here, take the high sigmas for the first sampler, take the low sigmas for the second sampler. The workflow is now becoming more and more opaque. But I just want to show it to you. And something else that is very important, the noise here has to go away. and for that we take a disable noise. So we hang that up here into the noise. We can first push it up. And if I've done everything right now, then we should now have made a noise injection with the sampler custom advanced. I haven't changed the prompt now. We'll just see if it works. It worked. We now have a picture with noise injection and the sampler custom advanced created. Split sigma's denoise is percentage calculated on the entire steps. That means we now have 20 steps. At 0 it would be nothing. At 0, 5 it is switched from step 10 to the next sampler. At 1 nothing would happen either, because then only the first one runs through. Yes, that was it for Flux Dev now. We will definitely see that more often in upcoming videos when new things occur. So let's move on to the next topic, Flux Schnell. So Flux Schnell. Let's take a look at the ComfyUI page again. Here we see Flux Schnell is a distilled for step model. Distilled means with the models, if you throw in a prompt, then the models know the way they have to hit and are therefore faster. Instead of orienting yourself crosswise in the model and looking together which tokens you need and so on, the distilled models more or less know their way and hit it. And that ensures that instead of 20 steps, you can only create a picture in 4 steps. So here it says, the model weights can be found here. And what we see here is that we also have to download 23.8 gigabytes for the fast model. That means you can generate pictures in fewer steps, but not with less VIM consumption. That's a little problem. So like Flux Dev, we get very quickly to VIM and RAM limits. And especially when ComfyUI has to try to shift this whole model between VIM and RAM back and forth, it comes back with performance losses. Nevertheless, download it and the whole thing comes in the unit folder. Where is it? Here in your models unit folder, and then we can load it. I pulled a workflow over here once. The whole thing looks like this again. I'll build it up again very quickly and take the case sampler, because I've already recorded the whole thing before. I've already recorded the whole thing and the problem was that OBS has crashed. That's why I'm trying the whole thing again with the case sampler. I don't know if the custom sampler might make a few little problems or something. Let's see. CFG of 1 is also important here, and we only need steps of 4 at the moment. Then let's swap out this safe image node. FluxRec. So and then, let's see. We have Flux up here quickly, then I have to change the model. I also take the FP8 here. I have to change Flux and the VAE. We take the prompt from just now. Where are my prompts? There, so that we can have a comparison. So, and then let's try to run the whole thing. That looks good. I pray to the gods of OBS that it doesn't crash again. So and now we have a picture with only 4 steps created. We'll take a look at the whole thing. Yes, we can already see the differences. In terms of quality, it doesn't come close to the dev model. We didn't get any blue fishnets either. We got a black pants, green shirt, brown coat, pink hair, neon, rain. The pictures are not bad, you really have to say that. However, the execution with model loading also cost me almost 160 seconds. Therefore, VIM is still needed, as with the dev only the pure rendering time is faster. I'll try a second picture again. I just did that too. That killed the recordings for me, but it already killed it in the first picture. Here the Q5 has to change to Flux. Let's take a look at how the model does the whole thing. Yes, we can already see that it is 2 times correct. You have to rate that positively now. However, this doesn't make sense. The Flux sign is there, our cat with spacesuit is there in front of a store. With another seat you can certainly do even more. In the previous recording, however, it also bleed a little. It didn't write a latent place on it, but a Lammens pluck or something. but it produces beautiful pictures in just 4 steps. Even if the model is loaded, it is very fast. The prompt was now 24 seconds for 4 steps. Normally I can do a 30-step SDXL picture in 24 seconds. It's faster, but VRIM still remains. Then I'll see what's next on my list. And that's the Flux FP8, which we'll take a look at next. Okay, let's take a look at the FP8 checkpoint. We go back to the ComfyUI example page. Simple to use FP8 checkpoint version. You can find easy checkpoint Flux here. Here we have it. This is a slightly smaller checkpoint than the original model. We see here that there are 6.5 GB missing. It is therefore a bit more friendly for not so well-equipped computers. And also mine, although it is actually quite well equipped. But yes, I'll tell you more about it later, but the whole thing is not even in your .NET folder. No, it's in your Models Checkpoints folder. Here I have Flux and here it is. But that's also described here. Here it says Checkpoints directory. Models Checkpoints. And then you can load the whole thing like a normal checkpoint. So with the load checkpoint node. Let's take a look at what ComfyUI gives us here. It's a very manageable workflow. Here, too, I take the new Save Image node and say FluxRec. After that typo, I'm not sure anymore if I just gave the right folder names or if I have a bunch of folders on my drive. So here again is the warning. We should set CFT to 1. That's what we do. I'll move the node away a bit here. Or it's already done. Yes, and here you can see it. I just have to jump into the folder again. That's just the Flux Dev FP8 Safe Tensors checkpoint. Everything you need is in there. We have the model, we have the clip, we have the VAE. A very normal checkpoint, only with a precision of 8. That means we don't have 16 bits anymore, but 8-bit calculations. It's a bit of a loss of quality. However, as we have seen, it is also smaller. And that's why it's better to handle. I'll take our test prompt from before. Copy it in here. Let the whole thing run once. And pray to the OBS gods that this recording will go through now. So there is our picture. What does it look like? Actually, a very nice picture. Brown coat. Why do I always say brown? Brown coat, pink hair, green shirt. It says Flux on it. We have black pants. But we don't have a blue fishnet. Then Dev was a little better. But it's also very filigree here. We have neon lighting, we have rain, we have. I don't know if it's Tokyo, because you can't see it again. We have this boat problem again. But it was also much smoother to let the whole thing run. I have now 130 seconds with model loading. I'll take our cat example again. I'll go through that again. And here we say we want to have FP8 on the sign. And I'll let that run again. Then we'll see how long it takes. There we have our picture. Is the recording still running? The recording is still running very nicely. I hope so. It's also quite nice, I think. Here I find the book even quite well combined with the text. Here it says FP8. Here it says Flux and scratches. That's a cat, probably scratched it. That's normal. It's still a nice picture. But what I just noticed, I often run into it. I'll show you the console now. I like it when the console is a bit transparent. That was the first picture I rendered. With our cyberpunk woman, we needed 3 seconds for an iteration. And with model loading it was 130 seconds. We have now used 194.8 seconds without model loading. You saw that yourself in the video. That was not edited or anything, just because I changed the prompt, and now the seconds went up to 9.35 seconds per iteration. I don't know what that's about. Down here you can unload the models and empty the cache. But I think there are still quite a few problems in this setup. ComfyUI also had problems with the memory management. It was patched and worked on it, but you saw that an increase of 3 times happened, just because I changed the prompt. So we didn't even have to load the model. But we still needed longer to render than in the original picture. I haven't gotten behind that yet. Sometimes it helps to unload the models, and then reload the model, so that you get to an acceptable iteration speed. This is the FP8 checkpoint. The first generation was 2 seconds per iteration. The next generation went up to 58 seconds per iteration. That means it took a minute per iteration. The annoying thing is, if you cancel here, you have to wait a step. That means, in the worst case, you press cancel and have to wait a minute, until the generation actually cancels, so that you can then unload the models. It was nice that I could show you how this happens. Maybe you have the problem too. I don't know what the problem is. That it suddenly goes up from 2 to 50 seconds, just because you change a prompt or switch a parameter. Well, this is the FP8 checkpoint. Nothing special, but much more VIM friendly. Also produces nice pictures. We go on to the next topic. So let's take a look at the quantized models. I have the link here. You can also find the links in the description. This is the model card. This is a GGUF conversion of the Flux Dev. Let's take a look. Here we see all the models. They go from Q2 to Q3, 4, 5, 6 and 8. What does that mean? In contrast to the fast model, which was a distilled model, the quantized models are also smaller in size. This is due to the fact that certain areas are compressed within the model. Therefore also the different file sizes. The smaller, the more loss of quality. But there is the possibility to use Flux Dev and at the same time to adapt to our RAM needs. I think FP8, wait, I can look again. The FP8 model was 17.2 GB large. Well, there is also a clip and something like that. The Q8 model is 12.7 GB. And the further you go up, the smaller it gets. The Q2 model is really not beautiful. You should also not use the S models. I'm still looking for the names for K and S. If you know them, feel free to comment. S models are not so good either. Better the zeros or ones. That's the baseline. I did tests with all of them. I can show you the pictures again, and then we go and build a workflow for it. It's not too hard. You have to download the whole thing. Where was it? In your .NET folder, where the others are already. And here we see all the quantized models. They come in the .NET folder. What we also need is the ComfyUI GGUF node collection. You can easily install it by opening the manager. Then you get it displayed here. And then you can press install. Everything is already downloaded. Then we start building something. We look for GGUF and then get the .NET loader. Here we can then select our models. I'll just take the golden middle. Then we need a dual clip loader. We need the T5. I also take FP8, and we need a load VAE. But we can also go to Flux and take our Flux VAE. Then of course we need a prompt. There is also a second node. If you look for Flux, then you also get the clip text encode. My goodness! Clip text encode Flux. We just had T5 and clip L. It's the other way around. You don't necessarily need the guidance here. But we can take it. but I will keep clip L and T5 the same. That means we say L to output and T to output, and then I'll just take a text node and send both in here. Here we have the guidance. If you want to separate that. As I understand it, T5 is better for the description of the main motif, while clip L can contain stylistic and/or background information. Then we need a K-sampler. We need an SD3, empty latent image. We can put that in here. The rest is actually as we have just seen it. We take a conditioning 0 out. We can also... Wait, I'm looking for Flux. Where is it? Or was it guidance? Flux guidance. No, I don't mean Flux guidance. Model sampling Flux. That's it. I'll leave everything as it is. I'll leave it anyway. Of course, we need our clip here. And we need a VAE decode here to decode our image later. We pull that over here. It's a little nicer. We say here save image and I say again FluxRec. So. And we need our prompt from just now to test. I'll hang it in here now. And if I haven't done everything wrong. Here's another mistake. Here we have to switch to Flux in the dual clip loader. Then we should be able to run that with the quantized models now. And it's not complaining. Very nice. I'll let it run through. And there was a mistake, of course. Well, who noticed it? Who has already written the comments? We have to set CFG to 1. So, we got our picture. Let's take a look at it. The font is a bit of a glitch effect. Well, artistic freedom. Nevertheless, pink hair, a brown coat, green shirt, black pants, blue fishnet, neon lighting, rain, Tokyo. I've never been there. I do not know. And of course a lot of bouquets. So, it also ran much faster. I have now used 42 seconds to create this picture. I'll do the second picture again. I can copy over it and say, but not Q5, but Q4, because we have used the Q for quantized model. I'll let it run again. You can see that it has a lot of influence. Q4 is, while it's running here, we can take a quick look. Q4 has 6.8 GB and the 1 is 7.5 GB. We are here with the 0, so the even smaller one. The quantized models are really good to be able to adapt to the conditions of the hardware. And they still produce beautiful pictures with text, with all descriptions. By the way, there are also quantized models from the T5 clip text encoder. I haven't tried them yet, but you can add them. There is also a GGUF dual clip loader for GGUF. With that you can load them. But it works pretty well. The cat doesn't hold the sign. It's just floating around. It's the first time a Pixar style. It's actually a nice picture. I think it's pretty good. This variant here, that you can switch a bit here. As I said, the S models could actually be left out. You don't need them. The Q2 is also bad. It's really low quality. From Q3, but it's an S model. Look at Q4. I think you're in the SDXL area. Going up. The higher the number, the better it is. Be a little lenient with your hardware. Nice thing, but also a small indicator that the open model community is trying to heal itself. The problems that Flux Dev and Flux Schnell cause on the local hardware. It looks like this is an attempt of self-division and to bring out quantized models, so that you still get the image quality, but also on local hardware. I'm looking in my notes. Next, we have the Flux LoRas. For the Flux LoRas, it's not that spectacular, but cool. I've already changed the workflow a bit. What do I show you in detail? Where do you get the LoRas now? I click on the link here. On the one hand, there is a Flux LoRa collection. Here you can see Disney LoRa, Art LoRa, Furry LoRa, Midjourney LoRa, Realism LoRa, Scenery LoRa, etc. You can download them here. They are also not really big. They are also used to push your image generation in the desired direction. If you want to make anime with the base model, you can add the anime LoRa to get a little more of this effect. With a size of usually between 40 and 50 megabytes. Let's be honest, with the model size, we don't care about 50 megabytes. Of course, another approach is ComfyUI. You can filter on LoRas. In the filter, the shortcut is F1, but in the filter is also Flux. Then you can just filter and see what there is for LoRas. For the application of the LoRas itself, this is our workflow from before, from the quantized model. We still have our Q for 0 down here. I haven't changed anything here. I just added a load LoRa node up here. From the Flux sampling Flux, I'll do it a little bit so that you can see it a little better. Up here in the LoRas. From here down the sampler. The same with the clip from our clip loader. Out here in the load LoRa. And clip down here in the clip text encode Flux. And here he could then load the desired LoRa. These are two from ComfyUI that I used to test. Now I just put the C64 Flux safe tensors in between. What I had to do was remove the stylistic description from our cap prompt, because I had Disney or Pixar style in it. That kicked in very hard. After I removed that, I got this picture here. It's not quite C64 yet, but you can see that it reminds of old C64 covers. With prompting you can still pull around a little bit. But the font is also done. So it's not particularly spectacular. But what I wanted to show is that it also works with the quantized models. That means you also have the option to adjust your hardware a little bit, and then still use the LoRas. Of course, this also works with the normal Flux Dev model. There's nothing more to say about it. Check out what you need on ComfyUI. There are so many LoRas coming out right now. Just have a little fun. Finally something uncomplicated with Flux. Next is the IPA. So let's take a look at the IPA. As an entry point, I'll take this link here. It's in the description, of course, and we'll take a look at the whole thing. XLab's AI Flux IPAdapter comes in version 1. Very nice. That sounds very good. What do we have to do first? We have to download the model for the Flux IPAdapter. That's a gigabyte again. But the clue in this story is that it doesn't come in the normal folders as we know them. But it comes in the ComfyUI Models XLab's IPAdapter folder. Unfortunately, it is not possible to use the extra models YAML or something like that to refer to it. No, it has to be in the local ComfyUI installation. At the same time, there is also a workflow here. I've already downloaded it. But we'll take a look at it again. It was trained on 512 and 1024. And we still need the custom nodes for that. Let's take a look at the manager and look for XLabs here. So we have Xflux ComfyUI here now. We have to install that. Although I don't know, we need it urgently. In any case, it will be needed later for the Controlnets. We load the workflow of the XLab's IPAdapter. XLab's IPAdapter workflow. Then we get the nice things here. It looks like cabbage and turnips. We have a LoRa node here that is not connected at all. We can throw it away. Then everything overlaps down here. I can still load the VAE. Let's pack it up here. Preview image I'll take away. Here we also see the double text encode node. Guidance is extremely high here. Let's turn down to 3.5. Let's see what else we have. Up here we have our reference image for the IP adapter. Here I take another load image node. The one from me, because here I have folders in it. For example, paintings Mona Lisa cropped. Hang it in here. The thing is, this XLab sampler is really not good. That's why I throw it away right away. It doesn't work without negative conditioning. But we remember Flux doesn't want to have negative conditioning. We don't need it for the IPA, but for control nets. We take a case sampler. Then we are on the safe side. We don't need the negative node down here either. Of course not. What we do here again is zero out. And stay true to our line. Now we need the model. For this we also need the node collection. And we take the empty latent. What did I do now? It's wrong. I have to put this to the positive and this to the negative. Well done, everyone who complained now. What the heck is he doing? Correct. Image crop can be used to crop a picture again before it goes into the IP adapter. It's a bit strange, because here we see the IP adapter is trained at 512 by 512, or 1024 by 1024 with 25 steps. Why was there 50 steps? I don't know. IPAs need a little more steps, it's clear. I'm staying at 20. I don't want to overdo it. That's all here. It's all crammed together. It's amazing. Now we have a little more order in here. The next point. Strength of 0.92 is much too high. We go in with 0.6. I'll show you some examples later from 0.5 to 0.9. But in the demo workflow it's much too high. And the nice thing is that we're here, if I remember correctly. We stay with Flux Dev FP8. But the thing is, here for the example, it would have to be in the unet folder. But we don't have it. I have the FP8 in the checkpoints folder. That means I throw it out. I take a normal load checkpoint. There it is. I want to take the Flux FP8. We don't need the dual clip loader anymore. We can put the model and clip over here. We don't need load VA anymore. Then we have cleaned up the workflow a bit better. That looks much more compact than what we saw in the JSON. If we throw them away now, if it's on 1024 by 1024 or 512 by 512, why do we make a width of 1024 and a height of 512? That's also confusing, guys. I don't know. I'll take our prompt again. Because I'm just lazy. I copy it into both places here. Should I run it? I'll let it run and we'll see what happens. Aha. Flux IP Clip Vision. Good point. Thank you, ComfyUI. We also need the Clip Vision variant. We also find it here on the page. Download ClipL model safe tensors. Here we go to the files and versions. And here we load the model safe tensors into our Clip Vision folder, which can then be in the ComfyUI models again. And that's not to be confused with the clip with big G or something. Or here with this one for the IP adapter. The patch 14336. That's a different one. I called it clip with large patch 14. You can also call it IP adapter Flux or whatever you want. That's definitely in the Clip Vision folder. Also the extra model YAML is working again. I'll pick it up here. That's not the 14336. That's this one here. And now we try the whole thing again. And there we have our first result. Yes, we can already see the difference to our previous generations. But what is that? It's really not nice. We can try to turn the whole thing up a bit. Here in terms of strength. But you really have to say that the IP adapter is not particularly good. It will probably come out a new one in a short time. You should maybe wait for it. Yes, and then the recording is gone again. We saw how it works. I showed you pictures with the different strengths and so on. Yes, try it yourself. As I said, I think there should be a new IP adapter, a new version that might be better. But that's how it works. I'll also show in this video if something is crushing. That's just part of it. If you have to work with such large models locally, then it can happen. Let's move on to the control nets. The last point we look at are the control nets. Unfortunately, I can't run that anymore. I didn't get it to work properly because we need Flux Dev. Nevertheless, I wanted to show it to you. I thought I'd show you the links to the individual control networks. But I don't do that. We can click on XLabs RE. On the community page of XLabs RE. If you scroll all the way down, you can see everything that XLabs offers. Here we have the ControlNets version in the 3.0 variant, v3. There is also a single version. But there is also a collection. Where is it? LoRa Collections. ControlNet Collection. Look, that was updated 2 days ago. What do we have here? Here we have the v3 and the HED v3. Then I'll give you the link. I only saw that in the video today. In the collection, there were only v2 variants. The v3 variants fluttered around here. I'll give you the link. I don't think there was a v2 variant of head. No, they jumped from v0 to v3. Anyway, in any case, there are also workflows here. You can download them. I'll load one in here. That's another one. I'll just download it. Can you workflow? I'll call it new. It's happening live right now. Something has happened between my preparations and it hasn't done that much. I can't let it go. You also have to use the ControlNet models. It doesn't go into the extra models YAML folders. You have to use the models XLabs ControlNets folder. Here you have to put the models. Otherwise the whole thing doesn't work. And when I see something like this, up here we can load the control nets. We'll take CANI. I don't know why there was a ControlNet 5000 here. What they have improved now is that Flux Dev is up here and Flux Dev was loaded down here. In the previous variant, Flux Dev was loaded down here. Up here, the FP8 checkpoint was set. I'll try to stumble through here. But as I said, I won't start it. Why is the CANI image stored here? That doesn't make much sense either. Back here we have a preview and a safe node. It's all so mixed up. The problem is this XLab sampler. We've already stumbled past it. Actually, we don't need a negative, but it only works with a negative. Here both models are loaded, but this time in a different order. As it is called in this clip text encode Flux node. Before we always had T5 and then clip L. It shouldn't matter, but it's confusing. But these text encode nodes should actually pick out the right encoder. What happens here is a normal control net. But it only causes me problems when I let it run. You can download the workflow here. For the most varied variants, we can look at example JPEG again. Oh wow. Anyway, doesn't matter. In principle, it is a normal Flux workflow now with the apply Flux Controlnet and load Flux Controlnet. In between, the whole thing came from the we find them like this. Here from the Xflux ComfyUI nodes. We have already loaded them for the IPA. And then it should basically work like every other control net. But I haven't got it running properly yet. It wasn't very nice, and I have to honestly say I gave up after such problems occur as we have already seen in the recording. But that's your entry if you want to try it. Good luck, have fun. I hope there is still a lot of work to be done. But the problem is somewhere else. I will address this in the last chapter of this video. I would like to give you my personal opinion. I personally think it was not a good move to switch to a 12B model. The last model we got was a 2B model with SD3 medium. And now the jump has happened to a 12B model. And all the backgrounds behind it seem a bit thread-like to me. The whole open model and open source community idea is, in my opinion, a bit levered out by the Flux Dev. Because in principle it is said here that it is an open model, you can test it, you can play with it, you can use IPA and control nets. But you're bad luck if you are limited with your hardware. And with limitation of the hardware is almost meant that you could put in a room either a 4090 and you can work more or less with it. Which also causes problems, because it is still very slow compared to the other models. Or you just have bad luck and have to see how you get along. And here you can use our Flux Fast model, but not Flux Dev, but of course there is also our Flux Pro. And the whole thing feels to me like the direction. Yes, here you have an open model, do it, test it, play with it, but in the end you are forced to switch to any cloud services to be able to use our model sensibly. And because you have to pay the cloud services pay us, and that is the real intention behind it. We have seen it ourselves in the video. There are always problems. It is sometimes a struggle to get the whole thing running and to keep it running. I don't want to rule out that it may also be in my hardware setup here that it runs partly better with you or probably also partly worse. Nevertheless, it is a problem that stops us from working sensibly with these models. From the developer's point of view, it is quite a struggle if you have to wait for a long time until the model is loaded and then debug your code and then cancel again, fix code, restart, and everything is reloaded again. That is of course difficult. From this point of view, we may be spoiled by the smaller models from before. Nevertheless, the jump from 2B to 12B is in my opinion too big. The problem that arises is that Flux is now, if you look at X and so on, is taken as a new standard. That means smaller models that could offer the opportunity to add additional models such as IPAs, control nets, etc. and load them into the VRAM. I am afraid that these models still have the chance to counter this current Flux hype. Also on YouTube, the videos I have seen are either these typical mind-blowing and it changes everything videos, or I had the feeling that people who have a bit of an idea of it reacted very behaviorally and neutrally. I also noticed that not much is shown, like the pictures that are generated, but that a cut is made and then the result is shown, which for me indicates that there are also local problems could have been. It is my assumption, but the problem is that Flux could be a new standard if you only look at the pictures. But that brings the problem that this local image generation suffers from it. My hope is now a bit that Stability AI will catch up. I think there is a 8B model planned, which will of course be big, but also leaves enough space in VRAM to be able to load more models. Even if we look into the future, I think Nvidia has announced the 5090 with 28GB VRAM and the 5090T with 32GB VRAM. Then that will also be a problem with a model size of 24GB VRAM. I mean, the VRAM will be full again. It is not the case that if we take a 5090 with 28GB VRAM, we put in a 24GB model, then we put in a 1GB IPA, then we put in a 1.5GB CANI Controlnet or something like that, and then we are already pretty fast at the limit. And that's what I mean. The model size is still the problem. I just said that these quantized models are already the first attempt to do something for the community so that we can still run the whole thing on local hardware. I was really a bit frustrated. Of course, the pictures are good, the prompt adhesion is good, it's also fun to create pictures with it when Flux is running properly. But I have the assumption that it is not really intended to support the open model community. That's just a vague argument that you can get it and use it. The real goal is behind it. It is clear that a company has to earn money, that is the goal of a company. However, I am a bit bothered by this. Either it's like Midjourney, where you can say, if you use it professionally, then buy it like that. But we are not an open model, we are Midjourney. But now this way to say, yes, this is an open model, so you can all work, but from our side it is an open model. But here is of course also the pro version, which you can then license and buy like Midjourney. And yes, we will then earn our money. I don't know, it has a thread of taste. It may also be that the frost of the last few weeks has stalled a bit with me, but those were the thoughts that I had in my head. We have also seen it here in the video. The workflows are also carelessly thrown together. I don't mean the workflows from the ComfyUI examples page, but the ones we loaded from XLabs. They were clapped together, lovelessly clapped to the brand. Here it works. What do you want? Partly also the organization of the repositories. That was also somehow strange. For me it feels a bit like a means of purpose to maintain the argument. We do something for the open model open source community, but the actual goal behind it is something different. And I don't want to start with the XLabs sampler. I don't think it's programmed very nicely. And if possible, I wouldn't use it. So, that's a bit of an unusual end for such a video. Normally I concentrate more or less on technical things, but I had to get rid of it. It's not all gold that shines. We got a model that makes very nice pictures, but in my opinion, it is somehow sold backwards with a different goal. I wanted to get rid of that. I don't know how you see it. I would only partially share this hype. On the one hand, of course, because of the good pictures, but on the other hand, because of the whole thing, I can't connect to it. Flux will of course continue to accompany us. We can't get rid of that now. There will be no step back from Flux. As I said, I just hope that Stability AI will come with an 8B model and then the corresponding IP adapters and control nets and so on. And that we not only get nice pictures, but also a little more control over the pictures and the picture generation. And that the whole thing still works on local machines, if not necessarily on this generation, then at least on the next. But even there I see a bit black with Flux, because who stops a company from saying, we don't do 12 billion parameters, but we go directly to 32 billion parameters. And then the model has easily 40 gigabytes. But here you can download it. Oh, your hardware doesn't fit in there, even if it's the last generation of the currently available consumer hardware. Well, but that's not our problem. We give you the open model here and, yes, you have to look at the rest yourself. I don't know, everything has a bit of a thread in it and I wanted to get rid of it again. But don't get pulled down, that's just my opinion. Maybe I'm wrong, hopefully, and it will develop in another direction. And we'll see you again in the next video. Until then, take care and bye.